Welcome back to the shop, guys. I hope everybody had a good Christmas and a new year. Been freezing cold in the shop here, so I haven't been able to do much, but I guess from the title, everybody knows what this video is about. And piece of advice, don't even attempt this until you've seen all the parts or whatever of me making this. And I did make a mess of recording it. I understand how now some people do incredible videos. It's because off camera, like Maddie's workshop, off camera they make one and now they know what to do. They know what they're doing. So now they make the one that they're going to record live. So what am I going to say? Don't attempt to do it until you've seen all the pieces. I do mention here coming up that there is only one other video out there that I found of a guy making the radial engine. And yeah, he skipped some parts and pieces, so I had a lot of questions. So in this video, I'm just going to show no machining, but just talking about it. And then I'm going to kind of sum up what I've learned at that point, that when I did record this. I wasn't done with the engine yet. So I'm going to sum up a little bit so you'll know kind of what's involved and what tools you need before you even attempt this engine. And then at the last part of this video, I'll really get into details about the engine, what I learned, and what you have to do to get it to run. This guy is running. First, I'm going to show a new toy, a dial indicator, and later on in this video, you'll understand why I'm showing this indicator. Okay, so I guess on with the show. This dial indicator. I picked it up off of eBay because I was thinking about making that coaxial indicator. Teeny thing, it was $7. It actually cost me $11 with tax and shipping, and the sucker is really nice. It's spot on. Teeny little screen. What is it? I think it was an inch. Yes, an inch and a half screen. But I'm using this in my Noga, and it's nice because it's small, and when you're on a mini lathe, you don't have too much room. Of course, made in China, came in a nice styrofoam protective box. But so I'm keeping this thing. This is really working out. These are kind of hosed up, but I guess luck of the draw. The sucker is on the money too, like within a half a thou, because I put it on some gauge blocks and checked it out. So put a link in the description if anybody's interested in it. Comes with a nice lug back, so pretty cool. Well, it seems every channel that I normally watch, everybody's busy building an engine of some sort. And a long time ago, I did build a flame liquor, which really pushed my skills and my machine's capabilities. But I managed to get it working. And then I had tried doing the bowl arrow and gave up on that. I just cannot get the compression, because that's the hardest part, is getting the piston and cylinder perfect. So I decided, and I downloaded turn it over, I guess. I can flip this in the video editor anyway, but a radial engine here, 3 cylinders, so this is really going to be a long project. Flip it over so I can see it. Kind of bad pictures of seeing it and so on, but when I got down to the print, it's like, really? Oh, this is upside down for me, but I don't know, kind of scattered around pieces and parts. And there was a point where I couldn't figure out how this thing goes together. So I'll put a link in the description. Of course, I went on YouTube looking for somebody who was making this engine, and there's only one out there. And the guy skipped some stuff. I mean, I know it was pushing him to do it. So if you want to see machining, go and look at his video of doing stuff and how he did it. Because so far I made a mess of trying to record this thing. So I'm going to try to see what I can do to recover some of the footage. But yeah, you need a special kind of setup. I mean, you need some special tools here in the shop to build this thing, because a lot of these pieces are really thin. So I'm going to break away and I'll show you, I already showed you the new indicator. I'll show you it in use, plus the chuck stop that you really have to be able to do a lot of these thin parts.
Yeah, lighting's probably not that good. I did show this indicator and you're going to get to see it in action here. That's too high. It should be on the 0. So it's moving. Something's moving. Huh? If I push this, yeah, there it is. It's rocking. So completely around here, one of these sides has to come up. Wow, is that really rocking a lot? Alright, who's off? Well, I gotta back it out and figure out what to do here. That's rocking because these two guys are hot. You see, this is solid. So this is, one of these guys is way off. So I guess I'll take him out until he stops rocking. So whatever this side is, I need to make that match it. Alright, put this on 0. It's hard to do. Alright, that's zeroed out. On the other side, should be 0 also. It is. So these have to go on 0. That's too high. So I gotta loosen that up a bit. Where is it? Actually, then the problem is the other side has to come up. Yeah, it's low. So this comes up to zero it out. There we go. Zeroed. And this side is too high. Is it moving? Alright, I gotta bring this one up to 0. It was low. Alright, well, you guys kind of get the idea of what I gotta do. There, 0. I gotta mess around with it.
So I did start building some of the pieces here, machining them in the chuck stop, the real thin stuff. But there came a point where I just could not figure out how this thing went together and how it even operated, you know, because you got this, I call them a piston rod, some people call them, what was it, cam rod or something like that. But I'm thinking, you know, how's this going to go around? It's going to hit the center, and I was going to give up figuring, okay, great, this is another set of prints like the bull arrow where it's not going to work. But then finally some light bulb went on. So I started doing my own set of prints in order of how this whole thing goes together. The air inlet goes on to the crankcase, and this is the cap for that, and the flywheel. And I did start doing the design based upon this flywheel. I don't know why I made it. I made it a long time ago, so nice chunk of brass, so I'm gonna use this for the flywheel on it. So some of the pieces, you know, I started with this guy. Okay, you know, there's the side view and this, and again, I'll make these prints when I'm done, all available to anybody who wants to make this engine. So this was pretty simple. You know, you're just putting it in the chuck, turn this side, put it in, and you use the touch DRO to do the whole circle function. And I've got radiuses and all that. So I made that piece, then I decided, all right, let me make the other side, which is also pretty easy to do. And I happen to have some air fittings. I hope they're big enough. If not, I can always re-drill, tap, make my own bigger fitting. I couldn't find anything online bigger or that was a decent size for this thing. So, okay, so I made that. I might show some machining of these parts, I don't know yet. Then I decided to make, you know, this little guy was pretty easy. The video of the guy making it did it a little differently. I just decided to take a 1/16 inch drill bit, snap it off, and I've yet to grind it down to length, and then just Loctite it in there. So this is pretty no-brainer. I did stupidly, as you can see, drill this hole on the wrong side, but looking at what it does and how it works, it didn't matter. This is just moving this valve around. So I made that guy, and I don't get their dimensions. These are the dimensions to the print, but moving this thing off, it looked like it was just going to break the side out. So I wound up backing it up a little bit and then drilling the hole. Should work. This guy too, pretty easy to make. You know, you're basically in the chuck stop, 4-jaw. Yeah, I highly recommend a 4-jaw too, because, oh yeah, on the chuck stop, I did it with 4 screws. Because if you think about it, if there's just 3 screws, you can tilt either side in and skew everything as you're tightening up the jaws. So, especially if you have a 3-jaw. So it seems like it's pretty tedious, as I showed, trying to get the thing straight, but it's actually easier than it looks. It works pretty easy. So yeah, 4-point mount on the chuck stop. This guy, yeah, easy, you know, put it in there, face it off, groove it, flip it around, so I can easily hold, you know, something like that in it. So that was this guy. Move him out of the way. Then here's the other print that I was working on for the rest of the engine, and I didn't want to use square cylinders on it, so I wound up, there it is, oversizing it. And again, I'll put all the dimensions on the print. Everything's lining up perfectly, this hole to the air hole and all that. So I'm pretty happy, and decided to paint it because you know, the flame liquor, it's all oxidized, looks terrible. This guy too is pretty easy to make. Just where's oh, it's over by the lathe. Just a blank, you put it in there, face it, run them, finish it off a little, put it in a horizontal bandsaw, cut it off, put it back in, do the other side. So I've got 3 more to make. There's the top of the cylinder. So where do I go from here? So yeah, I understand how it goes together, and I understand how it's supposed to work. The only thing I've got left is I've still got to do this. Oh yeah. This guy, if you're trying to do it on the lathe, if your compound or your headstock isn't perfectly aligned to the ways, you're going to wind up with a funnel. And that's what I was fighting on the flame liquor. If you try to do it in the mill, boring it out, as the head comes down, you wind up with the boring bar doing this number, you know, to a half, a thou, or thou. So you wind up with high spots and low spots. This guy I did with a 1/2-inch reamer. So I'm, because I forgot what they called out for the actual piston size. I think it was 5/8, and I don't have a 5/8 reamer. So I'm redoing the design for a 1/2-inch, and it is a beautiful fit. You know, there's no play. I have massive compression on this, which I don't think I'm going to need since this thing's just running on air it can leak all at once. But so that's the guy so far. The valve, did I make the valve? No, I haven't made the valve yet. It goes on this side. But all these pieces fit together perfectly, all the holes. Touch DRO is beautiful, the whole circle function for making this thing. So I'm really thrilled with how it's coming out. I don't know what I'm going to record next to try to show some machining, I guess. Yeah, I'll probably have to show lapping and making the valve and how I get it perfect. Same way with the piston, it's going to have to be a half-inch piston and an altered type of design. So probably next part I'll start showing some machining. Sorry, I didn't realize this part was off camera when I was talking about it. This is the one where you can see those holes here, and it should have been on the top. But again, I'm pretty sure it doesn't matter. There's no real sinking or anything to do. This is just going to spin this valve around. And this is the broken off 16th drill bit that I decided to use. And I'll take this over to the D-bit grinder and bring it to length. 2/10, so I got to take a lot off of it. Be very careful. I put this in the vise and just a pair of pliers snapped it and the pieces flew. So if you're going to do that, wear eye protection. I don't know where some of the pieces went in the shop, but wow, it really exploded. So yeah, this part's kind of a no-brainer to make. And again, I love using my Sanu 4-jaw chuck Zippo runout. Holds everything. I've already sold off the one of my 3-inch 3-jaws on Craigslist, and I sold off the 4-inch 4-jaw independent chuck on Craigslist too. So oh, and I didn't really talk about these guys. This was a idea from that one video I was talking about, the guy making it. These were finishing nails, perfect size. I just cut them to length, stuck them in a collet, threaded them, done. 440, yeah, these are 440s, yeah. I don't know why the original print calls out threading it so far on one side and a little bit on the other side. When I'm done with this whole thing, I'll correct the print so that everybody can have it. And I have a feeling this is all you need to thread on both sides. I don't know why one side, again, is so long, it doesn't need it. Because here's the piece with it in there. And I put the shallow side in the engine block and the long side's up here. But I have a feeling the lengths are wrong, because when I put the cap on this cylinder, these are going to be too short or something. So I need to actually probably redo all of them and make them exactly the same length. I just kind of randomly banged these things out so they're not all exactly the same length, right? If I try to push them together. Yeah, they're pretty close. That came good. So let's see. Well, I thought I'd just talk about all the pieces here. So you kind of know what I went through to make this, get it this far. So if you decide to build one, what you're going to be up against. The flywheel I made a long time ago. I didn't have a 1/4-inch reamer, so that hole is kind of off. So I just want to make do with it. Probably Scotch tape or something to get it to work. This part, and again, all these, the print I've updated as I built each part, and so everybody's going to be welcome to the print. You'd email me. My email's at the end of every video and the website. This is pretty easy to make. I had a piece of 1/4-inch 1144, Loctited it in there, 1/8-inch brass rod. A lot of these parts you're not going to be able to make unless you have a chuck stop or a chuck spider, they call it, either one, to be able to hold something that skinny. This is 243 thousandths, so that's pretty easy to make. This guy, first one, I made a mistake. I put this hole on the wrong side. Didn't think it was going to make a difference, but then I realized with this valve and the crank here that the pistons are in the wrong position for the valve letting air in and out. This guy too, pretty easy to make. I've got the touch DRO whole circle function to do all the hole patterns here, and I have a 1/4" reamer which I used for all the center holes. This is a precision part. This is the air valve, pretty tough to make, and it has to fit inside this cup. I can't turn it over here because of all the screws. It has to fit in there perfectly and airtight. Had some brass fittings in a jar that I'm going to try to use. So not too much to say about that. Again, chuck stop is needed. The cylinders, I changed the design from the original to 1/2 inch. I think it was 5/8. I wanted it, I didn't want the square cylinders, so this is what I came up with. Just a little teeny hole. To do these little grooves here, I basically put an end mill in and I went back and forth, eyeballing it off these holes until it looked like it was square, and then I locked it down, and these came out pretty good. You know, this one's a little off center, but who cares? It should work. 1/2 inch reamer too. I didn't do any lapping. It's a beautiful finish inside. The cylinder heads, caps, whatever, again, need a chuck stop. This guy, I don't know, this, yeah. For this guy, you needed a 1/16 inch pin, and I sacrificed the 1/16 inch drill bit, snapped it off, tool grinder, just take it to the length that I need. Same way with this, I bought for $3 off of Amazon a gauge pin that fits, cut it up, grind it off, perfectly fit. I'll show you how I made the con rods, piston rods, and these pins in the video here coming up. This guy is pretty easy to make too. You will need a boring bar to do this one, and again I used the reamer for the 1/4 inch hole. This guy too, reamer, 8 inch, 1/8 inch, I think that, yeah, it's 1/8, 125. So that's about all I can say. These are nails, and I started to finishing nails. I started a set with a re-threading die, and it was making a mess, so I switched over to a threading die and made them all. So they're clean threads. It looks nice. I like it. These are all 440s that I've used everywheres. So that's about all I can say on this thing.